Hello, in this video I am going to discuss problems of 20.2 of chapter 20 complex functions. So let's discuss the first question. The question is, find the invariant points of the transformation W is equal to Z minus 1 divided by Z plus 1. So given W is equal to Z minus 1 divided by Z plus 1, we need to find invariant points. In order to solve this problem, we need two concepts. First one is bilinear transformation. So what is bilinear transformation? A transformation W is equal to AZ plus B divided by CZ plus D with AD minus BC not equal to 0, which mapping the Z plane onto the W plane is called a bilinear transformation. That is a transformation W is equal to AZ plus B divided by CZ plus D. A transformation in the form AZ plus B divided by CZ plus D, where A, B, C, D are complex numbers, any complex numbers, with the condition AD minus BC not equal to 0. AD minus BC is, if you write it as a matrix, first element A, second element B, and third element C, fourth element D. Then what is AD minus BC? AD minus BC is determinant of the matrix. A into D minus B into C. Determinant of the matrix. Determinant not equal to 0 is the main condition for bilinear transformation. So W is equal to AZ plus B divided by CZ plus D with AD minus BC not equal to 0. This transformation mapping the Z plane to the W plane. And then this transformation W equal to AZ plus B by CZ plus D is called a bilinear transformation. Okay, that's our first concept. Now second concept, what is invariant points? What are invariant points? So if we have the transformation W is equal to AZ plus B by CZ plus D, with the condition AD minus BC not equal to 0, that is, we have a bilinear transformation, then invariant points are the points which satisfies W is equal to Z. So invariant points are the points which satisfies W equal to Z. That is, mapping the Z maps to itself in W plane. If we map Z to itself in W plane, then that points are called invariant points. Simply W equal to Z. Setting W equal to Z, we get point Z. That points are called invariant points. So these two concepts we need to solve this question. The question is to find the invariant points of the transformation W equal to Z minus 1 divided by Z plus 1. Clearly this is a bilinear transformation. Now what are invariant points? Invariant points are points which satisfies W is equal to Z. So setting W equal to Z. That means Z minus 1 divided by Z plus 1 is equal to Z. Now simplifying, Z minus 1 is equal to Z into Z plus 1. That is, Z minus 1 is equal to Z square plus Z. So Z minus 1 is equal to Z square plus Z, which implies Z square plus Z minus Z plus 1 equal to 0. That is, Z square plus 1 equal to 0. What is Z square? Square is equal to minus 1, which implies Z is equal to plus or minus I. imaginary number satisfies I square is equal to minus 1 and minus I square also minus 1. So z is equal to plus or minus I is the, plus or minus I are the invariant points. So these are invariant points of the given transformation W. The second question is, find the transformation which maps the points minus 1 I 1 of the Z plane onto 1 I minus 1 of the W plane respectively. Respectively means minus 1 maps to 1 and I maps to I, 1 maps to minus 1. Also find its invariant points. So first we need to find the transformation which mapping these points in Z planes into these points in W plane, and also find invariant points. The only concept we need to solve this problem is cross ratio, the concept of cross ratio. So what is cross ratio? The cross ratio of 4 points Z1, Z2, Z3 and Z4. We usually denoted by an open bracket Z1, Z2, Z3, Z4, which read as the cross ratio of Z1, Z2, Z3, Z4, which is defined as Z1 minus Z2. That means the first order suffix Z1 minus Z2, the first even suffix, then the next even suffix Z1 minus Z4 into the second order suffix Z3 and the closest even suffix Z4. Z3 minus Z4 divided by Z3, the next is Z3 minus Z2. The cross ratio of 4 points is defined as Z1 minus Z2 divided by Z1 minus Z4 into Z3 minus Z4 divided by Z3 minus Z2. Consider 4 points Z1, Z2, Z3, Z4 of Z plane and 4 points W1, W2, W3, W4 of W plane. If a bilinear transformation mapping these points in Z plane to these points in W plane, we have a result. The cross ratio is invariant under bilinear transformation. If a bilinear transformation mapping these points in Z plane to the points in W plane respectively, that means Z1 maps to W1, Z2 maps to W2, Z3 maps to W3 and Z4 maps to W4, then the cross ratio is invariant under bilinear transformation. That means cross ratio remains unchanged. The cross ratio of Z1, Z2, Z3, Z4 is equal to cross ratio of W1, W2, W3, W4 under a bilinear transformation. Since cross ratio is invariant under transformation, cross ratio of Z1, Z2, Z3 and Z4 is equal to cross ratio of W1, W2, W3 and W4. If the transformation mapping Z1 to W1 and Z2 to W2, Z3 to W3 and Z4 to W4, we can use this result of cross ratio to find the transformation mapping these points of Z plane onto the W plane. So what is cross ratio? Z1 minus Z2 divided by Z1 minus Z4 into Z3 minus Z4 divided by Z3 minus Z2. which is equal to W1 minus W2 divided by W1 minus W4 into W3 minus W4 divided by W3 minus W2. Now the points minus 1, I, 1 maps to 1, I, minus 1. We can take Z1 as minus 1, Z2 I, Z4, Z3 1 and take Z4 as Z. Now W1 equal to 1, W2 equal to I, W3 equal to minus 1 and W4 as W itself. So that we get a transformation including W and Z. That is W is equal to AZ plus B by CZ plus D. Now using the formula of cross ratio. It is minus 1 minus I divided by minus 1 minus Z into 1 minus Z divided by 1 minus I, which is equal to 1 minus I divided by 1 minus W into minus 1 minus W divided by minus 1 minus I. Now let's take minus 1 outside from here, which is equal to Z minus 1. So minus 1 from this, which is Z plus 1 into minus 1 minus I divided by 1 minus I. This is equal to, also take minus 1 outside. So you get 1 W plus 1 divided by W minus 1. Minus 1 from this and this cancel out into 1 minus I divided by minus 1 minus I. Next we are doing conjugate multiplication, that is denominator, conjugate of the denominator. 1 minus I conjugate is 1 plus I, multiplying both numerator and denominator with the conjugate of denominator. Also here also. So we get Z minus 1 divided by Z plus 1 into minus 1 minus I divided by 1 minus I into 1 plus I by 1 plus I, conjugate of 1 minus I, which is equal to W plus 1 divided by W minus 1 into 1 minus I by minus 1 minus I into conjugate of denominator, that is minus 1 plus I by minus 1 plus I. Now multiplying, Z minus 1 by Z plus 1 remains same. Now minus 1 minus I into 1 plus I. Multiply minus 1 into 1 minus 1 minus I minus I square is minus 1, so plus 1 divided by 1 minus I into 1 plus I. A plus B into A minus B is A square minus B square. Is 1 square minus I square is minus 1. So 1 plus 1 is 2. W plus 1 divided by W minus 1 into 1 into minus 1 plus I minus I square is minus 1. So plus 1 divided by minus 1 minus I minus 1 plus I. Again A plus B into A minus B is A square minus B square. A square minus 1 square is 1 minus B square. I square is minus 1. So plus 1. So 1 plus 1, 2 from here and here cancel out. Now what we get? Z minus 1 divided by Z plus 1 into, this is minus 1 plus 1 cancel. Minus 1 plus 1 cancel. This is minus 2I. And W plus 1 divided by W minus 1 into, this is 2I. So 2I cancel. What we get? Minus of Z minus 1 by Z plus 1 equal to W plus 1 divided by W minus 1. Next we do componendo and dividendo. That is numerator plus denominator divided by numerator minus denominator. So, we want to get W is equal to A z plus B by C z plus D. So, we use componendo, dividendo and dividendo. So, what we get? Minus of z minus 1 divided by z plus 1 equal to W plus 1 divided by W minus 1. That is minus z plus 1 divided by z plus 1 equal to W plus 1 divided by W minus 1. So, numerator plus denominator divided by numerator minus denominator. Numerator plus denominator divided by numerator minus denominator. So, what we get? Minus z plus z cancel. 1 minus 1. Sorry. This is plus 1. Numerator plus denominator z plus 1. So, minus z plus z cancel. 1 plus 1 is 2 divided by minus z minus 2z. 1 minus 1 is 0. Is equal to W plus W. 2W. 1 minus 1 cancel. Divided by W minus W cancel. 1 plus 1 is 2. Cancel 2. 2. That is what we get. W is equal to minus 1 divided by Z. So, this is required bilinear transformation, which maps minus 1 I 1 to 1 I minus 1. Let's check what give minus 1. Z is equal to minus 1. W is equal to minus 1 by minus 1. That is equal to 1. So, minus 1 maps to 1. That is equal to I. W equal to minus 1 divided by I. We know that 1 by I is minus I. Taking the conjugate multiplication. So, minus 1 into minus I is plus I. So, I maps to I. Now, Z is equal to 1. W is equal to minus 1 by 1. Minus 1. So, minus 1 I 1 maps to 1 I minus 1. So, this is the required transformation. W is equal to minus 1 by Z. Now, the invariant points. Invariant points are the points which satisfies W equal to Z. That is minus 1 by Z is equal to Z. It is minus 1 is equal to Z square. Z square equal to minus 1 implies Z is equal to plus or minus I. So, imaginary number plus or minus I are the invariant points of this transformation. Third question. Find the bilinear transformation which maps 1I minus 1 to 2I minus 2 respectively. Find the fixed and critical points of the transformation. First, we want to find the transformation which maps these points to these points. So, we want to find a transformation which maps these points to these points. Use the concept of cross ratio. It's Z1 minus Z2 divided by Z1 minus Z4 into Z3 minus Z4 divided by Z3 minus Z2. It is equal to W1 minus W2 divided by W1 minus W4 into W3 minus W4 divided by W3 minus W2. So, substituting the values, 1 minus I divided by 1 minus Z into minus 1 minus Z divided by minus 1 minus I, which is equal to 2 minus I divided by 2 minus W into minus 2 minus w divided by minus 2 minus I. So taking minus 1 outside from here and here, we cancel. What we get? Z plus 1 divided by Z minus 1 into 1 minus I minus 1 minus I. Then multiply the conjugate of the denominator minus 1 plus I on numerator and denominator. Same here, w plus 2 divided by w minus 2 into 2 minus I divided by minus 2 minus I into minus 2 plus I by minus 2 plus I. Multiplying the conjugate of denominator on numerator and denominator. So what we get? Z plus 1 by Z minus 1 remains same. So multiply 1 into minus 1 minus 1 plus I minus I into I square minus 1. So this is plus 1 divided by minus 1 minus I into minus 1 plus I again. A plus B into A minus B. That is A square minus B square is minus 1. So plus 1 equal to W plus 2 divided by W minus 2 into 2 minus 2 minus 4 plus 2I plus 2I minus I square is minus 1 plus 1 divided by A square is 4 minus B square is minus 1, so plus 1. Minus 1 plus 1 cancelled, so I plus I 2I divided by 2 and minus 4 plus 1 minus 3 plus 4I divided by 5. So we get Z plus 1 divided by Z minus 1 into 2I by 2 equal to W plus 2 divided by W minus 2 into minus 3 plus 4I divided by 5. So this 2 cancel. What we get? Z plus 1 divided by Z minus 1. Take this term to this side. What that? 5 by minus 3 plus 4I, already here an I, W plus 2 by W minus 2. Okay. Now Z plus 1 by Z minus 1, 5I minus 3 plus 4I, multiply with the conjugate of denominator minus 3 minus 4I divided by minus 3 minus 4I. W plus 2 by W minus 2. What we get? Z plus 1 by Z minus 1 into minus 15I plus, okay. Take this 5I outside, minus 3 minus 4I. So multiply this A plus B into A minus B, that is A square minus B square. 16I square minus 1, so 9 plus 16. W plus 2 by W minus 2. 9 plus 16 is 25. We can cancel 5 with the 25. Z plus 1 divided by Z minus 1 into 5 cancel. Here, this is 25. 5 cancel. That is minus 3I minus 4I into I. That is plus 4. I square is minus 1. Divided by 5. Which is equal to W plus 2 divided by W minus 2. Now use componendo dividendo. That is numerator 4 minus 3I into Z plus 1 plus denominator is 5 into Z minus 1, 5Z minus 5. divided by numerator minus denominator minus 5z plus 5. Now w plus 2 plus w minus 2 divided by w plus 2 minus w plus 2. Now take z outside. 4 minus 3i, there is a 5z, so plus 5. What remaining? 4 minus 3i minus 5 divided by z into 4 minus 3i minus 5 plus 4 minus 3i plus 5 equal to w plus w is 2w, 2 minus 2 cancel, divided by w minus w cancel, 2 plus 2 4. So what is this? 9 minus 3i into z plus minus 1 minus 3i divided by minus 1 minus 3i into z plus 9 minus 3i equal to w by 2. So take 9 minus 3i outside. 9 minus 3i into z, it is minus of 1 plus 3i. So minus of 1 plus 3i divided by 9 minus 3i divided by 9 minus 3i, take outside. This is minus of 1 plus 3i divided by 9 minus 3i into z plus 1. It is equal to w by 2. 9 minus 3i cancelled. Now make this as in the form a plus ib using conjugate multiplication, that is 1 plus 3i divided by 9 minus 3i into 9 plus 3i divided by 9 plus 3i, multiplying with the denominator, conjugate of the denominator. What we get? 1 into 9, 9 plus 27i plus 3i, 3i into 3i is minus 9 divided by 9 square 81 plus 9, which is 30i divided by 90. That is I by 3. So this is the complex number I by 3. For rewriting it, z minus I by 3 divided by minus z into I by 3 plus 1 equal to w by 2. That is, multiply with the 3, 3z minus I divided by minus iz plus 3 equal to w by 2. So 2 into, take it to this side, 2 into 3z, that is 6z minus 2i divided by minus iz plus 3, which is equal to w. So w is equal to 6z minus 2i divided by minus iz plus 3. Therefore, this is the required transformation, mapping 1i minus 1 to 2i minus 2. If you have any doubt, please substitute the values 1, we get w is equal to 2, and substitute z is equal to I, we get z is equal to, w is equal to I, and substitute z is equal to minus 1, we get w equal to minus 2. If you have any doubt, first substitute z is equal to 1. So 6 minus 2i divided by minus I plus 3 is equal to w. So in order to form this as a complex number a plus ib, in the form a plus ib, multiply with the conjugate of denominator, that is 3 minus I is denominator, conjugate is 3 plus I. divided by 3 minus I into 3 plus I is a square minus b square. 9 minus I square minus 1 plus 1. That is multiplying this 6 into 3 18 minus 6i plus 6i minus 2i into I square minus 1 so plus 2 divided by 10. That is minus 6i plus 6i, 18 plus 2, 20 divided by 10 get 2. So 1 maps to 2. Check other options. Z is equal to I, we get W equal to I. And Z equal to minus 1, we get W equal to minus 2. So this is the required transformation. W equal to 6z minus 2i divided by minus iz plus 3. Now let's find the fixed points or the invariant points of the transformation. W equal to 6z minus 2i divided by minus iz plus 3. Invariant points are the points satisfying W equal to z. That means 6z minus 2i divided by minus iz plus 3 equal to z. This 6z minus 2y equal to minus iz square plus 3z. That is 6z minus 3z is equal to minus iz square plus 2y. That is 3z is equal to minus iz square plus 2y. 3z plus iz square minus 2y equal to 0. Multiply with the minus I, so that minus I into I is plus 1. So this is z square minus 3i into z minus 2i into minus I into I is also, I square is always minus 1. Minus 1 to minus 1 is plus 1. This is minus 2 equal to 0. Now z is equal to, use minus b plus or minus quadratic equation formula. So minus b is 3i plus or minus root b square. That is minus 9. Minus 3i square is minus 9. Minus 4 into minus 2 is plus 8 divided by 2 into a is 2. So this is equal to 3i plus or minus minus 9 plus 8 is root minus 1 divided by 2. We know that root minus 1 is I, imaginary number, divided by 2. 3i plus I is 4i by 2 or 3i minus I is 2i by 2. So the roots are z is equal to 2i or I. So these are the fixed points or invariant points of the transformation. Now critical points of the transformation. W equal to 6z minus 2i divided by minus iz plus 3. Critical points are the points with the denominator equal to 0. The point z with the denominator equal to 0, that is minus iz plus 3 equal to 0, which implies 3 is equal to I z. That is z is equal to 3 by I. 3 by I. 1 by I is minus I, that is minus 3i. So z is equal to minus 3i is the critical point of this bilinear transformation. Hence we solved 3 questions in the exercise 20.2. If you have any doubt, please comment below.